Good morning, class. This is Mr. Walker here, and we are talking today about inverse operations. This is going to be a quick video because this part of our notebook is only one page, so let's get into it. So, the inverse operations are obviously the operations that are the opposite of each other, and we use them to solve any given equation. So, over here on the left, we have a little diagram so that you're able to just really solidify what's what. And then over here on the right, we have a couple of examples of inverse operations that you are going to fill in. Okay, so let's take a look at the inverse operations. So over here on the left, I have a couple of examples of those operations that you are going to need to fill in. And you are going to need to take them and drag them into one of these circles. What is it? Opposite of its opposite. That's probably not the best way to say that, but yeah. So let's look at addition. So we know that the opposite of addition is subtraction. So these two are both inverses. So if you ever needed to undo addition, you would have to do something with subtraction. If you had to undo subtraction, you would have to do something with addition. Now, over here we got multiplication. So to undo multiplication, we have to do division. And to undo division, we have to do multiplication. Now, one of my symbols happened to disappear on my end, but that's just, that's my fault. So over here we have the something to the second power. So this is an exponent. Now, the opposite of doing anything with an exponent is having something to taking the root of that exponent. Now let's see if I can find that square root symbol here. Can I? Nope, I'll just draw it. That's what I'll do. Okay. So the opposite of taking something to the second power would be taking the square root of something. So the square root symbol looks something like this. That's a little rougher, but you guys actually have the square root symbol in your book. Okay. So now that we got this done, over here to the left, we got some practice involving them. Now I'm going to do two examples. So these two up here and these two down here. And you guys are going to fill in the remaining ones. So we know that since 3 plus 5 equals 8, then that means that 8 minus 3 equals 5. And this may seem, real simple, and it is. We just got to make sure that we understand that. Now, since 8 plus 8 equals 16, we know that 16 minus 8 will equal 8. A lot of times when we go through and we're going to solve equations, some of these things can be determined, super easy. All right, now for this, we got some multiplication involved. So this time we got 12 times 10. We know 12 times 10 is 120. And we know that 10 times 12 is the same thing. It's still multiplication. It's still the same numbers. So that means that we should still get 120. Now in the reverse, if I do 120 divided by 12, that means I should get 10 because I'm doing the inverse of what I was doing before. And likewise, if I'm going to do 120 divided by 10, I should get 12. So these things should pop up just like how you would normally do any division or multiplication, but you're just noticing that all these different facts are going to happen within this group. So let's take a look at this one before I let you guys off on this. So I got 12 times 8. 12 times 8, that's 8 plus, so that is 96. Sorry, 96. Yep. 8 times 12, same thing. We got 96. Now over here, I'm looking for what number divided by 12 gives us 8. Now, if I went through and, actually thought about my little, bit of times tables, I would know that the only number that I can divide by 12 and get 8 would end up being 96. And likewise, the only number I can divide 96 by and get 12 is 8. So, pretty simple, pretty easy. So you guys are going to go through and you're going to knock out the remaining parts of this. All right, guys, I'll see you in the next video.